Here you go, guys. I'll try and keep this one short, but here's a little bit more of a comparison. There's actually two graphs to look at. Okay, the blue is the Comcams 280, the yellow is the Schneider LSP 58H, which I actually had both the cams in reality. Okay, and if you look at it, you could see this is a 6,000ths lift. You can see the advertised duration is a little bit longer on the Schneider. Okay, but when you get up to the 50,000ths mark, it's identical. Now this is the exhaust. When you come back down, the 50,000ths mark, it's a tad bit after it. I don't know if that's a degree or whatever it is, but then when you get down here, it's a little bit longer. But when you look at the intake, okay, the starting duration now, Comp says theirs is 230 at 50,000ths. Schneider says theirs is 230 and 224 in the intake. And here's where you see it. If you can see the blue line opens sooner. So the left is obviously sooner. Okay? They follow the same pattern. You can see the Schneider cam has a little bit more lift. And the downwind ramp is almost identical with just a tad bit more at the end. Okay, the only one that matches identical is the beginning of the intake stroke. All of them, the Schneider has just a little bit more and it gives it that little gentle of a ramp. Okay, but you could see the difference here. And the reason I'm showing you that is that's the actual chart of the lobe. Here's the flow using my heads as an example. Now, if this had a different cubic inch, different set of heads, there are other variables that would change this graph dramatically. Okay, that's why you see them flat on the top. Because the heads that I'm using on Junior's motor, we already know what the flow rate is. People have tested all this stuff. So by doing that, you could see, and he even says that the additional lift doesn't help on those particular heads at all. Now, if you put this cam in, say, Cutworm's engine, where with the porting, or my wagon motor with the porting that brings it flowing up to 600 and 700, you would see it rise. Okay, but you'd probably see both of them rise. Okay, but that's where you start to see the lift come into effect. Now this is the flow. This is how much air it's flowing. This has nothing to do with the lift. Okay, and they're still using the same graph, even though the plots are in different spots. Now, comparing the comps at blue and the Schneider at yellow, we're at the exhaust here, the intake here, with the Schneider cam, there's a 0.6 gain on the exhaust and a negative 2.2% loss on the intake. And they blame it right here. You could see the actual difference in the duration. Flows the air sooner coming in, even though he says it hangs open a little bit longer at the end. And they actually all do. That's why he gets the 0.6%, is it's hanging open, or it's starting sooner here, hanging open longer there. So that gives you the 0.6. They're opening at the same point. And if you notice, everything's moved over on the flow rate compared to the other chart. Okay? And it's a little behind because it's later. And then the graph is almost identical to them where it hangs a little bit longer. So, what would you see on the dyno? I don't have a clue in the world. To me, these cams are almost identical. So as identical as you can get for two different manufacturers grinding. Now, would you see a difference in 30, 40 horsepower? No. A couple, yes. And I'm sure that's going to be based on your exhaust. And, you know, there's other variables. Will that 6% help? And like I said, if you put this on a different set of heads, these numbers are going to be totally different. This is my engine, my compression, obviously my cubic inch, my heads. This is what I should expect to see. Now, he doesn't have my exact heads in his hand, but we flowed those heads. So, Junior's heads, as you know, have no work done to them. They still flow pretty good if you guys are looking at the numbers. I mean, you're coming up to almost what's it? You're coming up to almost 240 CFM on the intake with those heads. They claim that these heads stock flow better than like double hump heads fully ported, and I believe it. So, but with that said, I just figured I'd show you guys this. The last graph I showed you, I accidentally showed you the Schneider up against the Mike Jones cam. I didn't show you this part of it. I showed you that part of it, and you saw the difference. But if you still look, obviously the Schneider is still on the 0. Okay, and with a blue intersects, which is hard to see, is still 2 degrees over on the comp cams, and every cam he's grafted is 2 degrees over. That's why he has me advancing the cam. So that's going to bring, if you superimpose it over, that means all my lines will be over, because they go over as a set. You can't actually move just that point. You have to regrind the cam. So everything's going to get moved over. Okay? By doing that, it gives you a little bit more bottom end punch. By retarding the cam, it comes on later on. So, like he claimed in that thing, I'm going to have 0.35, so that's a third of a point of compression increase by doing this. So that should help aid in some bottom end and some vacuum for the power brakes, because I am really trying to get the power brakes in the car. So, and the car should go pretty good. So with that said, guys, I just figured I'd show you these graphs, and one day I'll find the charts that he's working on. I know this cam will be added to those charts. And like I said, the charts are based on your engine, your compression, your everything. So the chart won't help somebody with a 304 or 401 or a 327 or whatever it is. That all has to be graphed in. So, okay guys, I'll talk to you later.